Ladies and gentlemen, you are all welcome to my YouTube channel. In today's video, we are going to look at the concept of periodic table. What is periodic table? Periodic table is the arrangement of elements in order of increasing their atomic number. So generally, elements in the periodic table, they are arranged based on their atomic number. And what is atomic number? Atomic number is the number of protons that is present in the atomic nucleus of an element. Remember that we have what we call atomic structure. So in the atomic structure, we have two major components. We have nucleus and a shell. And in the nucleus, we have two fundamental particles of an element. And these two fundamental particles of an element are protons and neutrons. And then we have shell. Shell also, there is one very fundamental atomic particles, which is electron. So electrons have negative charge, while protons have positive charge that is found in the atomic nucleus. While the neutron is neutral, it doesn't have charge. So the sum of proton and the neutrons that are present in the atomic nucleus of an atom is what we call mass number. And then atomic number is the sum or it's the total number of protons that are present in the atomic nucleus. So we arrange elements based on the increasing number of neutrons in the periodic table. Like for example, we have sodium. But before we actually start looking at the electronic configuration of elements, we need to know that in period there are two fundamental features of periodic table. These features in periodic table we have period and group. So what is a group? A group is the horizontal. A group is a vertical arrangement of an element. The vertical arrangement of an element is what we call a group, and then the vertical arrangement of an element is what we call period. And we have 8 groups in periodic table, and we have 7 periods. An element in the same group have the same number of valence electrons. So, like for example, what is valence electron? When you say valence electrons, it means it's the total number of protons and neutrons that are found on the on the shell. So the total number of electrons that are found on the outermost shell of an electron is what we call valence electron. Like for example, let's take sodium. Sodium have atomic number 11, and of course, when you draw the electronic configuration of sodium, the first shell have 2 electrons, the second shell have 8 electrons, and then the last shell have 1 electron. So the valence electrons of sodium is 1 because there is only 1 electron on the outermost shell of sodium. And then in addition, we have the sodium have 3 shells. So because it has 3 shells, so it is in period 3. So the total number of shells indicates the total number of shells shows exactly the period to which an element belongs. And another example, let's take example of potassium. Potassium have atomic number 19, and in the first shell it has 2 electrons, second shell 8, third shell 8, and the last one have 1 electron. So because it has 1 electron on the outermost shell and sodium have 1 electron on its outermost shell, it means they have the same valence electrons. So therefore, sodium is in group 1, potassium is also in group 1. But in the case of period, sodium is in period 3 and potassium is in period 4 because it has 4 shells. And then the next thing that we are going to talk about is the block of the element. So generally in the periodic table we have what we call block of the element, and this block of the element we have S block element, we have P block element, we have D block element, and we have F block element, and these are the blocks of the element. Remember that S orbital accommodate a maximum of 2 electrons, P orbitals accommodate a maximum of 6 electrons, D orbital accommodate a maximum of 10 electrons, while F orbital accommodates a maximum of 14 electrons. Elements that are in S block, they are the element that their electrons last on S orbital, that they have their last electron on S orbital, and that is where they are called S block element. Take example of sodium. Look at the electronic configuration of sodium: 1s2, 2s2, 2p6, 3s1. So you see that there is only one electrons on the last orbitals. So because the last electrons is on s orbital, and that is why it is called s block element. So sodium is s block element. And then it is because by look at the number, the last energy level, the last energy level is 3. So that last energy level also indicates the period. So you can use orbital configuration to know the group and the periods to which an element belongs. How do we do that? First, try to understand what is the last orbital. Like for example, in the case of sodium, the last orbital is s, and what is the index number is 1. So because the index number is 1, that is why it is in group 1. And because the last energy level is 3, so that is why it is in period 3. And then another example is, of course, let's look at chlorine. Chlorine have atomic number of 17. So the first shell have, the first orbital will have 1s2, 2s2, 2p6, 3s2, 2p, 3p5, 3p5, 2s2, 3s2, then 3p5. If you look at it, so we'll see that the last electron and on p orbital. So that is why chlorine is a p block element. So any element that the electrons or their last electrons are found on p orbital is said to be, of course, a p block element. And look at this. Look at the chlorine. In the case of chlorine, we'll clearly see that chlorine have two energy level that are the same. The last, look at it. We have 3s and we have 3p. So if you are going to get the group of chlorine, what you are going to do is you are to add the index number of the last energy level and second to the last energy level. So second to the last energy level is 3s and last energy level is 3p5. So you take the index number. So 2 plus 5 is 7. So therefore chlorine is in group 7. And then the next thing is also we have. So follow me in the next video to see the continuation of this lecture. Thank you.